Sharma, Assistant Professor, Ajay Kumar Garg Engineering College, and today I am going to start with lecture 3 for the subject, that is data communication network. And in this lecture we will going to study about addressing, how the addressing is being done. In the previous lectures we have discussed about the introduction of data communication, how the network will be formed, different topologies, that how the different devices are connected in a particular network. Then in the second lecture we have discussed about the different layer task, TCP IP OSI model, we have discussed this, and then in this lecture we will going to study about the addressing, how the addressing will be done, how you are going to address a particular device, because every device which is connected in a network, that is a node, that will be a computer, that can be a whole computer, that can be a printer, that can be a scanner, or any device that you have connected to form a network, that has their own physical address which is unique, that has their own port address related to the application. So, we will going to discuss each one by one. So, addressing, there are 4 levels of addresses are used in the internet employing the TCP IP protocol. So, let me introduce first thing what is TCP IP once again. In case of TCP IP, that is transmission control protocol, internet protocol, it has mapped 7 layers of OSI model to 5 layers of TCP IP. In these 5 layers, there is first layer is host to network control, then internet protocol is the second layer where 4 different protocols are there. Then next one is the transport layer where 3 different protocols are there, that is TCP, UDP and SCTP. And at the 4th layer there will be an application layer where different applications are associated, whatever application you want to perform on device B. So, that is been related to the 4th layer of the TCP IP. Now, the addresses are there for different there are 4 different levels of addresses. First one is the physical address, that is device specific, printer is having their own physical address and computer is having their own physical address, logical address, port address and specific address. So, there are 4 different types of addresses are there, that is associated with that we are going to use in TCP IP protocol. So, these are the 4 addresses: physical address, logical address, port address and specific address. So, specific address is basically associated with only single application. I want to take printout from the printer. So, it is having their own address. Physical address is device specific. Logical address means if I want to find a logic or a program I have written and I want to access some take a output of that particular program, that is specific to that, that is logically based. So, that is known as the logical address. Next one is the port address. There are different ports are there, like in microcontroller there are different ports are there. So, that is associated with a port address. So, these are the addresses. So, what I am going to, how you are going to see this much more easier way, you can understand in easier way. I am going to discuss some examples, some real time examples I am going to discuss, in which their different addresses are being used. And before that I am going to show you the relationship of addresses and the layers in the TCP IP. I have discussed that there are 5 different layers of TCP IP. These are the layers of the TCP IP. This is physical layer, data link layer, network, transport and application layer. So, these are the 5 different layers of the TCP IP model. Now, these are mapped to the addresses, that is physical layer, logical address, physical address, logical, port address and specific address. Now, you can see that in case of this physical address and data link address underlying physical networks, physical address is associated, okay, which is device specific, which is related to a particular frame that we have formed at the data link layer, because we have seen that in case of data link layer we have to add header, we have to add the trail bits, and the in between these header and trail bits the message will be inserted. So, in this way the method, or in this way the frame will be formed. So, that is known as the data link layer. The next layer is the network layer. In case of this network layer, there are IP and other protocols. What are the other protocols? ICMP, IGMP, ARP and RARP. I have shown you in the previous lecture also. In the network layer, there are 4 different protocols are associated, and to this protocol, if you want to access, it will be accessed through a logical address. It will be accessed through logical address associated with each of the internet protocol and other protocols like ICMP, IGMP, RARP and ARP. At the transport layer, there are 3 different protocols are there. This is transmission control protocol, user datagram protocol, this is streamline control transmission protocol. So, these are the protocols that is associated with the transport layer only associated with transmission purpose. Why? Because at the physical layer, data link layer, network layer, you have already formed particular kind of frames that you want to transmit, and whatever information you want to transmit, it has to be transmitted through a transport layer. So, there are different protocols associated with that, like transmission control protocol, what synchronization data you have to add, what synchronization has to be added. User datagram protocol means you are associated with user. So, for that particular thing you want to access, it is done through this port addresses. So, port addresses is related to the transport layer. Now, next is the application layer. To this application layer, there are different processes are involved with this, like telnet is associated with this tele network, then SNMP is associated with this FTP, DNS. So, these are the different applications or the processes that is associated with the application layer, and this is application specific. So, this is basically the associated with this specific address. So, there are 4 addresses are there. You can see that what are the mapping of this addresses and the layers are there in the TCP IP. Physical layer, data link layer associated with this physical address, network layer associated with this logical address, transport layer is associated with port address, and then application layer is related to the specific address. Why specific address? Because we do not require every application has to be used at the same point of time. It can be used at different, we can use different applications also. So, this is the mapping or the relationship of the addresses with the layers of the TCP IP. Here we are not talking about the OSI model, because in the previous lecture we have already seen that how the 7 layers have reduced to 5 layers in TCP IP. Now, we are heading towards how this addressing part is been done, how we are actually going to transmit the data, how we are actually going to access a particular device. So, that will be done using addresses. So, I have said that how you are going to understand this thing easily, we are going to use the we are going to see the different examples. Now, first example is this one. This is in figure 3, a node. First I am going to read the statement, then I am going to discuss it. A node with the physical address 10 sends a frame to a node with a physical address 87, which means sender the physical address. What is physical address? Physical address is device specific. It is associated with transmitter, receiver, whatever device you have involved in communication. It may be a printer, it may be a computer, it may be a keyboard, it may be a monitor or scanner. So, the sender physical address is 10 and the receiver physical address is 87, that is defined in the question only. 2 nodes are connected by a link bus topology LAN. We have used bus topology. LAN is local area network, which means in a particular office or in a particular small area we have set up a network which is based on the bus topology. Let me remind you what is bus topology. In case of this, this is the diagram you can see, this is cable and this is cable, and these two intermediate 4 intermediate nodes are there. This is the sender, this is the receiver, and these are connected through drop lines and a tap is there at every point. So, that is the example of bus topology LAN. LAN means it is associated in a particular short area we have set up a network. Now, as the figure shows, the computer with physical address 10 is the sender and the computer with the physical address 87 is the receiver. Now, let me just explain this diagram in detail. First thing, this is based on bus topology. This is the bus topology. These two are cable ends. It is associated with LAN. LAN means in an office in a small area. Then this is the sender. This is the first computer. This is the receiver. This is the second receiver computer. The physical address of this sender will be 10. The physical address of this receiver will be 87. The physical address of this computer is 28, the physical address of this computer will be 53. Now, these are the frames that has been found. You can see that how you have to provide the data, how you have to insert the addresses, like this is the destination address which is 87 physical destination address, this is source address physical source address, means 87 computer 87th 87 device having address is going to receive the data. The physical address device which is having the address 10 will going to send the data. This is the data and this is the trail bit. So, this is nothing, it is orange color is showing the header. So, in total you can say that this is a kind of frame that has been formed, which consists of the header information, which consists of the trailing information. Header information is nothing, it consists of the trail bits, data and the header bits, and then it will be transmitted towards the receiver side. Then this is the data which is been going to transmit the information. Now, next device, which because we have not mentioned the destination address as 28 and 53. So, what it will going to receive the data, but it will going to check that whether the receiving information, whether the receiver address is matched with the computer or not. It will not going to match, then it will be transmitted forward. Destination address does not match, the packet is dropped to the backbone or the LAN, then it will be received over here, it will not match again, then it will be finally it will going to be transmitted to this receiver. So, this is how the physical address plays an important role in forming the header. Whatever computer wants to transmit the data, whichever computer wants to transmit the data, it has to form a header which consists of the physical address of the transmitter and the receiver both. This is the first example. Second example is, most local area networks use a 48 bit, that is 6 byte, because 8 bits is equals to 1 byte. So, you can calculate a 48 bits or 6 bytes physical address written as a 12 hexadecimal digits. Every byte is separated by a colon and as shown below. So, this is how in the first example we have seen that how you are going to form a header, how you are going to form the trail bits, how the frame will be formed for the transmission purpose. In this example, we will see that how you have to write that particular address. Now, you can see that all of the local area network, or you can say most of the local area network uses this physical address which is written as 12 hexadecimal digit. Now, a 6 byte or 12 hexadecimal digits physical address is written like this, and these are separated by the colon. So, this is, you can say that this is nothing, it is the separation of the hexadecimal parts. 2 hexadecimal digits is separated by the colon. So, this is first hexadecimal digit, this is second hexadecimal digit, and this is fourth, and this is on. So, this is B is been used. So, which directly shows that it is a part of hexadecimal, because in hexadecimal notation we are using the alphabets after 9, 10 as used as A, 11 is used as B, and so on. So, this is how the representation will be done in case of local area network addressing, which is of 48 bit. Now, this is another example, that is figure 3 shows a part of internet with 2 routers connecting the 3 LANs. So, this is complicated example. Basically, there are 3 LANs are there which are connected, like you can see, this is first LAN, this is third LAN, this is second LAN. these LANs are connected through routers, which is router 1 and router 2. Each device has a pair of addresses, that is logical address and physical address. Till now we have seen two examples. In the first example, we have used physical address, how the physical address is used to form the frame. Second example, we have seen that how we have to write a particular address in the form of hexadecimal, and two hexadecimal digits will be separated by a colon sign. In this example, we will see the use of both the addresses, that is logical address and physical address. 3 LANs are there connected through 2 routers, then a pair of addresses will be there. In this case, each computer is connected to only one link and therefore, has only one pair of addresses. Pair of address means logical and physical address both are used. Each router, however, is connected to the 3 networks, only 2 are shown in this figure. So, each router has 3 pairs of addresses, one for each connection. So, this is first LAN, this is the sender, okay, and this is the sender one. Now, this at the sender side, this is the data, which the original data is generated by the sender, which is the raw data, which is has to be transmitted. Then it has to be transmitted through this network layer. This is A and P, this is physical address and logical address is there, and then this address will be added. This is the sender this is the destination physical address, this is the receiver physical address, and this is basically the logical address. So, this is how the frame will be formed at the data link layer. Now, the data will be transmitted through this data link through this LAN, and it has to be received at the router. Router itself is having their own address, it has to be added together with the data. Now, you can see that this has been received and it is having this data, it has been changed from 2010 to 3399. So, this is the destination router, this is 33 and this is the sender source one, that is 99, you can see. So, this data is also appended now, appended means this is also now changed. So, physical address is basically changed. Why physical address is changed? Because a router is involved in between LAN 1 and LAN 2. Now, in this case LAN 2, there the data will be received, which is having the address, that is 33, this is 33, let me show you, this is 33 and this is 99. What is 33? 33 is the destination address, 99 is the source physical address, this is AP logical address that you have added, and this is the data and the trail bits. Now, since it is 33, it has to be now changed to 66 and 95. Why 66? Because 66 the address of this router, second will be the 66 one, it has to be changed, then it is received at the LAN 3. Physical address again changed because the second router is involved in the communication. Then the data will be transmitted through this transmitted through the next LAN, that is LAN 3, and this is the receiver, basically this is the receiver. So, from the starting from the LAN 1 to LAN 3, the data has to be transmitted, and in between these two LANs the router will be there. So, this is 95, this is 66, this is the data that you have transmitted. Then this is the logical address and this is the data, and the same way it has been received. Now, you can see that 95 is the destination physical address, the device physical address. So, this is the example, that is how the networks are involved, like 3 different LANs are there, how intermediate nodes are involved like routers, each having their own physical address. The data at every point will be changed by means only the physical address at every point will be changed, because intermediately we have different routers or devices are there. This is another example. Figure 4 shows 2 computers communicating via internet. The sending computer is running 3 processes at this time with port address A, B and C. So, port address is basically related to the processes that are been involved with the sending computers. First process is having their own port address, that is associated as A, which is mentioned in the question. Second process is having their address B, third process is having their address port address C. The receiving computer is running two processes at this time with the port address J and K. So, let me summarize this. Port address A, B and C is associated with the sender, then port address J and K is associated with the receiver. So, three processes are being performed at the sender side and two processes are performed at the receiver side. Process A in the sending computer needs to communicate with the process J. So, this wants to communicate with this one. Note that although physical address change from hop to hop, means from one device to another device, like from one LAN it will be passed through to the another device, that is the router. So, the physical address will definitely going to change and the port address remain the same from the source to destination. So, basically logical and port address will remain same, only the physical address will going to change because of the intermediate devices which are used over here. So, this is the view of the question that has been explained. Three processes are there, port addresses are there, that is A, B, C. To the first device sender, to the receiver there are two processes having port address J and K. A wants to communicate with J. So, how the data will be there? A is the transmitter, J is the receiver, this is the data, then A and P is the logical address, then again the data will be changed and then it will be received like this. So, this is an example of port address. So far we have discussed about physical address. Let me remind you again, physical address is associated with devices. Every computer, every printer, every hardware will have their own physical address. At every hop you can say, or every next location, physical address will going to change, but the logical address and the port address will always remain the same, because it is associated with the destination only, to the main destination you want to transmit or the application you want to access at the receiver side. Next example is a port address is a 16-bit address represented by one decimal number as shown. This is how the port address is shown. A 16-bit port address represented as one single number. So, this is how a 16-bit number will be, port address will be shown. Previously, we have seen that how the physical address will be shown through this hexadecimal. In this, we have seen that how the port address will be shown. Physical address will change from hop to hop, but the logical address usually remain the same. So, in the first example, we have seen about physical address, how the physical address is associated with a particular device. It will going to change whenever we are going to transmit the information from one device to another device. Every router or every any hardware device will have their own physical address. Secondly, we have seen in the next example, we have seen that how we have to write the particular address in the hexadecimal form. Two hexadecimal digits are separated by a colon sign. Then in the next we have seen that how these devices, how this logical address and port address comes into the picture. Port address is associated with every application or every process which is going on device A or device B, then how this data will be transmitted. So, this is the next example. Then port address is a 16-bit address basically that has been written in a single form. So, these are the examples which from which you can understood that how these addresses are associated with the TCP IP layer. This is the reference that you can go through frozen book in which the data communication and networking, where you can see more examples associated with the addresses. So, thank you. In this lecture we have seen about the different addresses of the TCP IP protocol.